Hello, my name's Matthew Brennan, and this video is going to be a crash course on creating a 3D scan and taking it all the way through 3D editing software to a physical 3D print. I've been working with 3D scanning and 3D printing for about the past 10 years, and recently I've gotten a number of requests for a sort of explanation of the process that I use. There are a number of reasons one might want to do this. I'm planning on using all of these in graduate and undergraduate classes that I'm teaching on art history, Renaissance art in the case of Donatello's David, and ancient Greek and Roman art, sculpture in the case of the Ludovisi Gaul and the Pasquino group. So these are 3D prints are a great way to not only study the form of sculpture that you obviously very rarely would have access to the original sculpture. So these can be used in place of studying the original. They are smaller, and so that makes them easy to manipulate. You can get viewpoints of them that you wouldn't necessarily be able to get on the original, like looking at it from above or below. And unlike plaster casts, which are usually used in lieu of studying the original, these are extremely accurate. So these are accurate in proportion and pose to the original, whereas plaster casts often are not. And because this is meant to be a relatively condensed rapid-fire video, I'm not going to go through all the details of 3D scanning and 3D printing and photogrammetry and the different types of 3D printers. I'm just going to talk about what I use and the way I do it, and that should give you, if you're interested in learning more about any one of these technologies, it'll give you the vocabulary and a starting point to go off and search through the tons of information that's out there. What is a 3D scan? A 3D scan is an accurate, three-dimensional digital model derived from a real-world source object. In other words, it's a digital duplicate of something that exists in the real world, and it's accurate both in terms of scale, but also its visual fidelity. In other words, it will have a photorealistic appearance. There are a few different technologies that can be used to achieve this: laser scanning, photogrammetry or photoscanning, structured light scanning, just to name a few. So the first thing you'll need is an object to photograph, and it's important that the object is not reflective, it's not transparent or translucent. So the best objects are ones with a lot of what I call visual texture, sort of a rough surface with a lot of variation in color and texture. So for this example, I'm going to be using a plaster cast of a ancient Roman marble sculpture. It's called the Pasquino group. So once you've picked a suitable object, the next thing you'll need is a digital camera. A smartphone camera like an iPhone works fine. Ideally, you would have a high-resolution digital SLR or a mirrorless camera. I use a Sony A7R2, which is a 42-megapixel mirrorless camera. And the third thing you'll need is photogrammetry software. There are a number of different software out there, both open source as well as commercial. The most popular probably is one called Agisoft Metashape, formerly called Photoscan, and it is a really good compromise of performance and price. And finally, you need 3D editing software, and this has an asterisk because it's optional. You can definitely take your photogrammetry scan and throw it straight into the 3D printing software, but if you want the best result and you want the most control over the outcome, it's best practice to use a 3D sculpting software to either clean it up or to make it suitable for printing. And I use ZBrush for that. What follows next is a super condensed time lapse of the photogrammetry process, wherein you move around the object taking tons of photographs, and you try and get the object to fill the camera frame. I'm only showing sort of one circle around the object right here, and then that will transition into the 3D model. And what's happened in between is processing it through the photogrammetry software and then taking that 3D model into ZBrush and polishing it up. So just smoothing out the surface, making sure that the model is watertight, that means it has no holes, and usually leveling the base, so making sure that the model is oriented correctly and that it sits flat upon its base. Once we have a model that we're happy with, we can export that from either the photogrammetry software or the 3D editing software and bring it into the 3D printing software. It's usually called a slicer. But before doing that, I'll talk a little bit about 3D printing as a technology and the specific 3D printer that I use. So in order to create a 3D print yourself, you can always order one from a company like Shapeways, that one of these online 3D print services. But in order to create a 3D print yourself, you'll need a 3D printer, which is the machine that extrudes the filament and creates the print. You'll need filament, which is the material that, in the case of fused deposition modeling, is the material that the printer melts. And then you'll need the slicing software. You'll need some 3D editing software maybe. And finally, to clean up the print, you'll need some elbow grease using pliers, scissors, a penknife, sort of whatever you have at hand. So first of all, there are a number of different types of 3D printing technology. I use one called FDM, Fused Deposition Modeling, and that is a technology where a heated nozzle on the printer, which is on a gantry that moves back and forth, a heated nozzle extrudes a heated up plastic, essentially, and it deposits that plastic according to layers in the 3D print. So I'll show exactly what I mean by all this in a moment when I talk about the slicing software and the various 3D printing softwares. But the specific 3D printer that I use is called a Prusa i3 MK3S. My first step is usually to import the 3D model as an OBJ into a program made by Autodesk called Mesh Mixer, and all I use Mesh Mixer for is checking the integrity of the model and positioning it on the print bed. In other words, making sure that the model is oriented correctly. And occasionally, and I will in this case, I'll use Mesh Mixer to create supports for the model. Because of the way that 3D printing technology works, you almost always need, unless you have a very specific type of model that was built in a way that it would not need supports, you almost always need these support structure or scaffolding. And that is just throwaway material that you have to discard at the end of the print, but it serves the purpose of holding up the model while it's being printed. And in the time lapse of the print, you'll see an example of that, and then I'll show it a bit afterwards. Once I've created the support structure, I export both the model and the support and then import those into a slicing software. In this case, I'm using the Prusa slicer. So here we can look at the model and position it on the print bed, which is what we're seeing here. And we can also slice it and then look at the various layers. So this gives you quite literally a cross-section of the way that the object will print. And you can see the infill, you can see the various types of layers, whether those are borders or sort of shell layers. And we can look at it layer by layer. Now, a visualization like this gives a really great insight into the way that this fused deposition modeling works. And that is that the printer lays down one layer of material at a time. And the distance between these layers, that is the layer height, defines the quality and also the print time of the model. So for example, this print is at 0.15 millimeter layer height, meaning that each time the printer finishes a layer, it moves up 0.15 millimeters. That's a relatively high quality print height. Something like 0.3 millimeters would print much faster, but it would have a lower resolution. This print was about 6 inches tall, and it took 14.5 hours. Once we've sliced our model, we put it on an SD card, we put that SD card in the printer, and we begin the print. So without further ado, here is a time lapse of a 14-hour print. This is what the 3D print looks like straight off of the printer. And yes, we printed the Pasquino group, not the Laocoon, but those snake-like structures are the support, the scaffolding that the 3D printer needs in order to be able to deposit the higher up layers onto some structure, so that it's not simply extruding the material into the air with nothing to support it. Okay, we've got our print and some tools to break off the scaffolding. And the one that I've grown to really like is this little eyeglasses screwdriver, because it really allows you to sort of very finely get in there and just sort of begin breaking this off. So just like that. And removing these supports is by far one of my least favorite parts of the 3D printing process, but if you're methodical about it and just go slowly, usually you can do it without too much headache. Some of the ones you can just get off just by hand, just by pulling them off. But for most, you'll need a little tool like this, and you may even need to apply quite a bit of leverage to break it away. So I'll go through and do that. Okay, we've just got all the support off, and even though that that one scaffolding here broke or failed during the print, it doesn't seem to have too greatly affected the underside of his hand is a little messed up here, but that can be cleaned up with a heat gun or something to sort of blend that in with the rest. Otherwise, it's just about exactly as the 3D model is. One more little piece of support here. So the key thing when you're getting this support off is you want to use leverage rather than sort of, because you don't want to damage the other parts of the print when you're trying to pry off the support. As I said earlier, this is the Pasquino group, which shows a event from the Trojan War. It's Menelaus, the guy in armor here is either Menelaus or Odysseus, carrying the dead body of Patroclus from the battlefield. Patroclus was a friend of Achilles, who, when Achilles would not fight in the battle, Patroclus put on the armor of Achilles to inspire the troops, and obviously, like Achilles, he was not invulnerable or not an expert fighter, and he was killed on the battlefield by Hector. So this sculpture shows the aftermath of that event, where Menelaus or Odysseus, this older bearded soldier, is carrying the dead body of Patroclus from the battlefield to be cremated, and Patroclus is shown in either, I guess in this case it's probably pathetic nudity. He's brave but has been defeated and is dead. So he's obviously no longer wearing the armor of Achilles, and that is the entire process from 3D scan, photogrammetry scan, to a physical 3D print in PLA using a fused deposition modeling printer. Hopefully this has been informative or at least entertaining to watch. I did have fun making it. It took quite a while, and it actually took 3 prints because I didn't think to film taking the support off the first time I did it, but that is a interesting process, and it would be a shame to go through doing the printing and then to actually damage your print while you're taking the support off. So hopefully my method of doing it using a little metal tool will be helpful, and my advice is to go slowly and be methodical about it and work with a lot of care and carefulness. If you have any questions or comments, feel free to email me or leave a comment on the video.